Welcome back, guys. My name is Kagiso, and today we'll be doing sequence and series. And this question was taken from Mathematics Paper 1, June 2024. So, without wasting any further time, let us dive right in. So, the question says consider the geometric series 4 plus 2 plus 1 plus 1 over 2. And they are asking, let's just write it, 4 plus 2 plus 1 plus 1 over 2. And the question says, does the series converge? And we know that to converge simply means to meet. Ne? And how do you know whether the series converges? We know this by the R value, which is the ratio. This ratio must be between 1 and -1. Okay, and how do we get this R? The R is actually equals to 2 over T1. And this can also be, we can also say that it is equals to T3 over T2. Okay, and we know that this is T1, this is T2, T3, T4, and we can simply just substitute our T2, which is 2, and our T1, which is 4. This is going to give us 1 over 4. And by this, we can simply say that, let me just say 2.1.1. Yeah, we can simply say that, yes, the series does converge because the R value, 1 over 2, is between -1 and 1. Okay. Alright, moving on, they are saying calculate the sum to infinity. And we know this, they are gonna give you the formula for sum to infinity, which is A over 1 minus R. And we know that A is actually our first term, okay? Yes. And in this series, we know that our A is 4 and our R, is actually 1 over 2. We have just calculated it. So now, doing this problem, we're going to get 4 over 1 over 2. And this is simply 8. Okay? And that's it. And the last one, which is question 2.2. Given that from k to 10, which is equals to 29520, calculate the value of k. Let's just write it down. So it's 2.2, the sum to 10 values, where p is equals to k, 3 to the power p minus 1, which is equals to 29520. Am I correct? Yes, I am. So first and foremost, I want us to remember to expand this. It's simple. We are going to try and get at least 3 terms. But how are we going to get that since p is k? It's simple. We're just going to increment this k by 1 each time. So what am I saying? We're going to say k is the first one, ne? And then k plus 1, k plus 2, and so on and so forth, k plus 3, and so on and so forth. And these terms we are going to submit into p each time we do it. So let's do it and stop blabbering, okay? So what are we gonna do? We're gonna say 3 to the power p. Where we see p, we substitute the first term, which is k in this state. It's gonna be 3 to the power k minus 1 plus this following one, 3 to the power, where we see p, we substitute this one, which is k plus 1 minus 1 plus, we're gonna continue where we see where we see p, we're gonna substitute this one. So it's gonna be 3 to the power k plus 2 minus 1, and so on and so forth, until we get term number 10. And where we see p, we are going to sub in the last term, which is the value of 10. Therefore, it's gonna be 3 to the power 10 minus 1. And there you have it, which must be equals to 29520. Okay, now let's just clean up a bit. We'll be getting 3 k minus 1 plus 3 k plus 1 minus 1 is simply k, plus k plus 2 minus 1 is simply 3 to the power k plus 1. And then you have it. Right, 3 to the power 9. And this is what we have, which must be equals to 29520. And good people, let us recall from our formula sheet and from the question itself. They are saying this sum, keyword sum is actually equals to 29520. Okay, and there's a formula. Fortunately, they're gonna give you also, there's a formula that they've given you guys, which is this formula of S of n is actually equals to, let me recall, a into Rn minus 1 all over R minus 1. And now from here we have the sum already. We have the sum, which is actually this 29520. We want our a, we have a, we want r and also n. And how are we gonna get these terms? All right, so this is our first term, which is a. How do we get r? Recall, we just said r is equals to t2 over t1, which is also equals to t3 over t2. Okay, and substituting, this is our t1, t2 and t3. All right, so we have this r is actually equals to 3k over 3k minus 1. And we know that by our exponential rules, you can rewrite this as 3k over 3 to the power k times 3 to the power minus 1. Okay, and which simply we are gonna get 1 over 3 minus 1, which is actually equals to 3. And there you have it. That's our r value. And just to confirm, we know that T3, which is this one, is actually plus k, and T2 is k. We can expand it by using the same exponential rule, k times 3 to the power 1 over 3k, which is still actually 3. And then you have it. We have the value of r. Let me write it on the side. We have r equals to 3. We have S of n equals to 29520. We will have a, which is first term, 3 k minus 1. And now we want n. Now the question is, what is n in this state? Let us recall before anything else. Our n value, this one. Can I erase this? Yes, I can. Our, yeah, guys. So we know that our n value, from the S of n formula, a a to the power n minus 1 over r minus 1. We know that this a indicates how many terms, so it's actually the number of terms it takes to get the sum value. And how do we get that? We are given this sum equation. We know that the number of terms it takes to get this 2952, it's actually the top part, which is 10, the top minus the bottom plus 1. Okay, so how are we gonna do this? So our n value is actually equals to 10 minus k plus 1, and you can simplify it to be 11 minus k, and there you have it. We have our n, which is 11 over k. We have our a, we have our s, we have our r. Let us substitute everything, rewriting that equation as of n, which is equals to a to what? Yeah, a into rn minus 1 all over r minus 1. Substituting 29520 is equals to our a value 3 to the power k minus 1 into our r value 3, our n value 11 over k minus 1 all over 3 minus 1. And simplifying, we're going to get, pressing the calculator, 2 times 29520, we are going to get 2 times 29520, we are going to get 59040, which is equals to 3k minus 1, 3 to the power 11k minus 1. Okay, yes. Now simplifying, now I'm gonna take this and multiply it out. We know this method, I believe it's called the FOIL method. Now we're gonna get k. Remember, when bases are the same, we add the exponents. Therefore it's gonna be 3k minus 1 plus 11 minus k. We add the exponents, minus this just remains as 3k, k minus 1, yes, which is equals to 59040. Okay, sharp. And simplifying, we are going to get this as k minus k 0, 11 minus 1 is 10, so therefore it's 3 to the power 10 minus 3 k minus 1. Taking this one this side and this one that side, we are gonna get 3k minus 1 is equals to 3 to the power 10 minus 59040, and this is actually equals to pressing my calculator, 9. Yes. After getting this, we know that we can rewrite our 9 as 3 to the power 2. Bases are the same, we can simply equate the exponents. K minus 1 is equals to 2, and we have our k value as 3. And there you have it, good people. I hope this was informative enough, and if there's any question, feel free to comment down below, and remember to like, subscribe, share. You never know who might need to see this. And yeah, that's what we have for today. I hope you guys are okay, and yeah, Good luck.